Welcome to the Quick Start tutorial series for VisualCam 2015, brought to you by Microsoft. Today we'll be demonstrating the Mill module. Before we begin, let's talk a bit about the VisualCAD display. When you run VisualCAD for the very first time, your screen may look like this. These windows on the left belong to plugin modules that are currently loaded. For now, let's close all of them. Now, let's begin by launching the VisualCam Mill module. From the Plugins pane of VisualCAD's home ribbon bar, you will see the VisualCam 2015 main menu. Drop down the menu and pick Mill to load the Mill module. Docked on the left, you will see the Machining browser and the Machining Objects browser. When you first run VisualCam, these two browsers may be docked side by side. However, you can move them anywhere on the screen that feels comfortable for you. For example, let's move the Machining Objects browser so that it displays under the Machining browser on the left. Simply left-click and hold the title bar of the browser and drag it around on your screen. While doing so, you will see the docking widget display in the background with directional buttons, allowing you to choose screen locations relative to the active window. We'll drag the Machining Objects browser over the Machining browser until the cursor activates the bottom directional button. When the preview of the new location displays, let go of the left mouse button and the browser will move to that location. You can also resize the height and width of each browser, making sure that all the command icons and menus are easily accessible. Now, let's load the part model for this tutorial. From the VisualCAD main menu, select Open. Locate the VisualCam 2015 Quick Start folder shown here. Then select the VisualCAD part file named Mill Quick Start Tutorial and then pick Open. Then, from the View toolbar, select the ISO view icon. We will perform the following basic steps in machining this model. First, we will define the machine and the post-processor to use. Then, we'll define the machine setup, including the stock geometry, material, and work zero. Then, we'll create and select a tool to use for machining. We'll create the machining operations, including the feeds, speeds, the clearance planes, and other cutting parameters. Then, we'll generate the toolpaths, simulate the toolpaths, post-process the toolpaths, and then generate shop documentation. Let's start by defining the machine to use for this job. From the Program tab, select Machine to display the dialog. Under Machine Type, set the number of axes to 3 axis. Pick OK and notice that the machine type now appears under the machining job in the Machining browser. Next, we'll define the post processor. From the Program tab, select Post to display the dialog. For the current post processor, select HOS from the list of available posts. Then set the Posted File extension to NC. Other file extensions are available depending on your machine requirements. Pick OK and notice that the post type now appears under the machining job in the Machining browser. Now, let's define the machining setup. If there is no Setup 1 listed under your machining job, the system automatically creates one when a work zero or an operation is generated. However, by default, the MCS or Machine Coordinate System is already aligned with the WCS World Coordinate System, so this step is not required for this part. However, in production, you can have multiple setups and assign different machining orientations for each. In this step, we'll define the raw stock from which to cut the part. From the Program tab, select Stock, and then select Box Stock from the menu to display the dialog. Under Dimensions, set the length L to 10.0, width W to 6.0, and height H to 0.125. Note that the stock dimensions you enter here are measured from the corner of the bounding box selected in this dialog. Pick OK and notice that the stock type now appears under the machining job in the Machining browser. If the stock does not display on the screen, select the Stock Visibility icon located at the base of the machining browser. Once the stock model is created, you can move it in alignment with the part if needed. From the Program tab, select Align, and then Align Stock from the menu to display the dialog. For Z alignment, select Top, and for XY alignment, select Center, and then pick OK. The stock is now aligned to the center of the part in the XY and the top of the part in Z. Next, we'll set the material for the stock geometry. From the Program tab, select Material to display the dialog. For material, select Wood from the list of available materials and then pick OK. If the material texture does not display on the stock, select the Material Texture Visibility icon located at the base of the machining browser. Now that the stock is aligned to the part geometry, in this step we will establish the work coordinate origin. This location defines the 0 point from which all toolpath points are interpreted by the controller. From the Program tab, select Align, and then Set World CS. Then select Set to Stock Box. Then set 0 Face to Highest Z and 0 Position to Southwest Corner. This sets the machine home to the top of the stock material and the southwest corner of the stock geometry. Pick OK, and the part and stock geometry are now transformed to the World Coordinate Origin, or WCS. Alternatively, you can use Work 0 to set the work coordinate origin. Instead of moving the part and stock to the WCS origin, this moves the machine coordinate system origin to the specified location. From the Program tab, select Work 0 to display the dialog. Select Set to Stock Box. Then set 0 Face to Highest Z and 0 Position to Southwest Corner. This sets the machine home to the top of the stock material in the southwest corner of the stock geometry. Now pick Generate and notice that the MCS is translated and that the Work 0 now appears under Setup 1 in the machining browser. To machine the part, we will now create a 1/2 inch flat end mill. From the Tools tab in the Machining Objects browser, select Create Edit Tools to display the dialog. Select the Flat Mill tool icon. Then set tool name as Flat Mill 0.5 in the tool diameter to 0.5. Under the Properties tab, set Material to HSS and set the tool number to 1. Now switch to the Feeds and Speeds tab and pick Load from File to display the dialog. From here, set Stock Material to Wood and Tool Material to HSS. Pick OK, and the computed cut feed rate and spindle speeds are transferred to the Speeds and Feeds tab of the Tool dialog. Now pick Save as New Tool. The tool is created and listed under Tools in Session on the left. Pick OK to close the dialog. Notice that the new tool is also listed under the Tools tab of the Machining Objects browser. Now we're ready to create our first profiling operation. From the Program tab, select 2-axis, and then Profiling from the menu of 2-axis operations. This will display the 2 1/2 axis profiling operation dialog. Under the Control Geometry tab, pick Select Drive Containment Regions. The dialog is minimized and allows you to select 3 inside hole features to machine. Select the first region by picking the top edge of the larger center hole. Repeat this step for the 2 smaller hole regions. Press Enter or right-click to end the selection. The 2 1/2 axis profiling dialog comes back up, displaying the selected drive regions. They are also highlighted on the part. Notice that selecting a drive region from the list highlights the corresponding surface edge curve on the part. Now we switch to the Tool tab of the dialog. Select Flat Mill 0.5 under Tools. The 0.5 inch flat end mill is now selected as the active tool. Note that the tool parameters of the currently active tool are always displayed in the status bar at the bottom of the Machining Objects browser. Now switch to the Feeds and Speeds tab. Select the Load From Tool button. VisualCam will retrieve the feeds and speeds parameters that were set when the tool was defined and associate them with the current operation. Next, we'll switch to the Clearance Plane tab. Set the clearance plane definition to Automatic and the cut transfer method to Clearance Plane. In the automatic mode, VisualCam will determine a safe Z height for locating the clearance plane. Setting the cut transfer method to Clearance Plane will force all transfer moves to be performed in this predetermined clearance plane. When this dialog is active, the clearance plane is shown on the graphic screen. Now we switch to the Cut Parameters tab to control the cutting. Set the stock to 0. This means that we will not be leaving any thickness on the part after machining. Under the Cut Start Side section, check the box next to Use Outside Inside for closed curves, and then select Inside. Alternatively, you could use the Determine Using 3D Model option. In this case, VisualCam would use the 3D model to determine which side of the curve to place the cutter for machining. Now, select the Cut Levels tab and set Location of Cut Geometry to At Top. Enter 0.125 for the total cut depth. The cut depth is always set as an absolute value. This automatically sets the rough depth and rough depth per cut to 0.125. Next, we select the Entry-Exit tab. Entry-Exit parameters control how the cutter will engage material as it begins cutting and how it leaves the material as it completes cutting. Set entry and exit motions to none. Now pick Generate. The 2 1/2 axis profile toolpath is generated and the operation is listed under Setup 1 in the machining browser. The toolpath is also displayed in the graphic screen. Note that the display of the toolpath in the graphic screen can be turned on and off by selecting the toolpath visibility icon located at the base of the machining browser. The new toolpath can now be simulated to display the in-process stock model. Switch to the Simulate tab at the top of the machining browser. Under Preferences, uncheck Simulate by Moves and adjust the slider to set the simulation speed and then select Play from the Simulation tab. Additional simulation controls are available on the menu, such as stop, pause, etc. To view the cut model with textures applied, select the Material Texture Visibility icon located at the base of the machining browser. Now, we will turn our attention to machining the outer profile of the part. Again, we will create a simple profile toolpath, this time around the outer periphery of the part. Switch to the Program tab in the machining browser. Select the 2 1/2 axis profiling operation we just created. Right-click on the selected operation and select Copy. Now, right-click again and select Paste. This creates a copy of the operation and places it below the original in the machining browser. Now, right-click on the second operation and pick Edit to adjust its parameters. Pick Remove All under the Control Geometry tab. Now pick Select Drive Containment Regions. Select the top outer surface edge of the gasket and then right-click or press Enter to end the selection. Now switch to the Cut Parameters tab and change the Cut Start Side to Outside. We'll accept all of the remaining parameters and then pick Generate. The new 2 1/2 axis profile toolpath is generated and displayed on the graphic screen. Now, we'll select the new 2 1/2 axis profiling operation, select the Simulate tab, and then pick Play. Now, with the toolpaths complete, we're ready to post-process to an output text file containing G-codes that can then be sent to the machine tool to actually machine the part. Select Setup 1 from the machining browser and right-click and select Post. This will post all operations created under the setup. By default, the part file name and the setup name are appended for the G-code file name. Also by default, the posted G-code file is saved to the folder where the part file is located. Now pick Post and the G-code file is displayed in Notepad where it can be viewed or edited manually. Now close Notepad. At any time, you can create an informational report of your machining operations. Switch to the Program tab in the machining browser. Select Setup 1. Right-click and select Information to display and print the report. This dialog provides an estimate of the machining time required for the operations in the setup. You can perform the same right-click sequence on the machining job to determine the estimated machining time for all setups. Now pick OK to close the information dialog. You can also create a setup sheet by generating a shop document. This is typically used to instruct machine operators on how to set up and machine the part on the CNC machine. Select Setup 1. Right-click and select Shop Documentation. Select Template 1 and then click Save. This creates an HTML-based shop document that can be viewed in a web browser. You can perform the same right-click sequence on the machining job to generate shop documentation for all setups. This completes the Quick Start tutorial of the VisualCam 2015 Mill module. For further assistance, you can visit the online help supplied with the program or visit www.mechsoft.com for additional tutorials. Thank you.